Good morning, everyone. My name is Anastacia Ndimbo, a GIS specialist from Tanzania Geothermal Development Company Limited. Today, on Natural Resources User Conference, I'm going to present the applications of GIS in geothermal exploration. Have listed down 5 contents of this presentation, starting with the introduction. Tanzania is one of the countries with geothermal resource in East Africa. Most of the identified manifestation sites are located in areas transacted by the East African Rift System. Such areas include the northern volcanic province of Kilimanjaro, Meru and Ngorongoro, and the Rungo volcanic province in southwestern of Tanzania, together with the coastal areas. As you can see, the left side of this slide is a map representing the East African Rift System and the Western Rift System. And the coastal, you can see the coastal here. So, and the right side of this slide, you can see the locations of all manifestations in Tanzania. The distribution of all manifestations are here located somewhere here. And this means that the manifestations are following the extent of East African Rift System, which is here. That's why you can see most of the manifestations are here right away. And some are here at the coast, and one manifestation at the northern part of Tanzania. Previously, the government of Tanzania didn't spot out a specific company to deal with geothermal energy or to harness and develop geothermal energy. But after the government of Tanzania discovered the importance of geothermal energy, in 2013, decided to establish Tanzania Geothermal Development Company as a subsidiary of Tanzania Electric Supply Company, which is TANESCO, for the purpose of harnessing and developing geothermal in the nation. The company is empowered for the purpose of spearheading geothermal development in the country. Geothermal is the energy generated and stored within the Earth's surface. It is produced by radioactive decay of elements, and it's also transferred to the Earth's surface by conduction and conversion. There are also advantages of geothermal energy, which includes, as we all know, that geothermal energy is a renewable energy source, and it's also a base load energy source. It is environmentally friendly because you cannot find the destruction of any environment to anywhere where the geothermal projects are carried out. Also, it's less affected by weather fluctuations. It does not depend to any weather, and it is operated in a low cost. But generally, geothermal is an important component in energy sources mix and is a green energy source. Geothermal is tapped through drilled wells that target the geothermal reservoir. And as you can see, this is the geothermal reservoir. To explain a little bit, when the rainwater are penetrating beneath the Earth's surface, there are some amount of water which are tapped in the reservoir, and this is what is make a geothermal reservoir. Geothermal exploration referred to search of a geothermal reservoir, intended to identify the location and extent of a geothermal resource. Several studies are conducted during exploration, which mainly include 3Gs and exploration drilling. 3Gs refers to geology, geochemistry, and geophysics, which are a series of surface studies conducted to locate and quantify the geothermal resource. You cannot locate and quantify the geothermal resource without conducting these 3Gs: geological studies, geochemistry studies, and geophysical studies. studies should be conducted first in order to locate the geothermal resource. Findings from 3Gs enable development of a geothermal conceptual model, which is confirmed by drilling. And this is an example of the geothermal conceptual model. To explain a little bit, cold water resulted from rain penetrating tend to infiltrate and penetrate through beneath the Earth's surface, where then they get contact with the hot rock. Here is the hot rock. Then the cold water gets heated here, and after being heated, the water loses density, which then forced it to come out on the Earth's surface. If the water meets with structures like faults on between, which are located on the Earth's surface here, the water penetrating to the Earth's surface and form different geothermal manifestations like hot springs, geysers, fumaroles, mud pools, hydrothermal alterations, geothermal crashes, and young volcanoes. This is now the main theme of this presentation today, the applications of GIS in geothermal exploration. Geographic Information System technology represents the most modern methods of handling location-based data. GIS has the ability to create spatial databases, which are geodatabases which are more applicable to geosciences studies, that represent information in terms of GIS data models. Apart from that, GIS also has a wide applications in geosciences, from basic mapping to more complex activities like modeling of geological and geographic processes. And some of the applications includes identification of geothermal fields, geoscientific data collection, mapping manifestations and structures, siting of exploration wells, analysis of geoscientific datasets, interpretation of geoscientific datasets, geoscientific data management, and GIS also can create story maps. Starting with the identification of geothermal fields, GIS can be used to locate areas with geothermal potentials, which are usually associated with high thermal activities. Geothermal potential areas are identified on the basis of different datasets, that is 3Gs, geology, geophysics, and geochemistry. These data are integrated using GIS and used to enable decision making. So the 3Gs are found on separate ways, and in order for the decision makers to make a decision, they have to be integrated using GIS. And after being integrated, then it makes easy way for the decision makers to make the right decisions, especially on locating the areas for geothermal wells. For example, this is the geothermal sites in Tanzania. As you can see, the integration of geological data and hot springs together with the structures, different structures. The background of this map is a geological map resulted from the geoscientific datasets, geological datasets collected to the site, and created the lithologies, as you can see, with different colors. So this is the geological map of Tanzania, but this map has been overlaid with the structures, different structures and faults, as you can see, the black lines, and also have been overlaid with the hot springs in the green cycles, represented as the green cycles, small green cycles, this one and this one. These are manifestations found in Tanzania. And these are all areas with the manifestations or in terms of hot springs in Tanzania. GIS also can be able to enable data collection through GPS satellite images, area photographs. As we can see, I've shown the most tools which are useful in collecting geoscientific data. For example, a geologist can take to the site the handheld GPS in order to collect all the geological information, location sites, location stations, and identify all the structures and collecting the coordinates of the structures and creating the lithologies, different lithologies. And also, differential GPS is more useful when conducting geophysical datasets. For example, when taking gravity measurements, the differential GPS becomes more applicable because it is used to collect the coordinates of all gravity stations and all where the gravity measurements are carried out. Geothermal well site selection is a multidisciplinary approach done by integrating field data acquired by geophysical, geological, and geochemical, among techniques. The combination may include surface geology, location of geothermal manifestations, geomagnetic and gravity measurements, thermal data, temperature gradient and heat flow, the geochemistry of surface manifestations, and remote sensing data. As you can see this map, this is the geophysical map, a resistivity map, overlaid with the topographical map. As you can see the contours, but the wells also have been overlaid, and some of them have been identified for the purpose of harnessing geothermal energy. And also, it has been spotted out with the possibility zones presented by P10 zone, P50 zone, and P90 zone. Apart from those useful, geographical information system also can be used can help to minimize human errors by identifying the prospect area through overlaying different data layers. As you can see, this is the geological profile and this is the geophysical profile. This profile has been overlaid different lithologies, and for this can help the decision makers to identify the areas, the possible geothermal areas, and locate the geothermal wells. As you can see, there is hole number NB1 and hole NB3 around here. And this one, the resistivity map has been overlaid with the contours to identify where the geothermal wells can be located. As you can see, this is the NB4 and NB5. But there is hot springs around. This is Shongo, and this is Ngozi hot spring around here. And this is the Cap Rock. So now you can know where the geothermal potential is. Also, this is the map overlaid between geological map and geophysical map, which is the resistivity map on top of it. And this will help decision makers to make decisions on where to locate geothermal wells. As you can see, the locations of the different wells around the map. But also, this map has been overlaid with the hot springs. These red dots are the hot springs of this area. Also, this is the map, topographical map, overlaid with the wells. The aim of this map is to identify the topographical nature of the located wells of this area. Geothermal exploration requires the analysis of data by combining various sets of geoscientific information through GIS such as geology, geochemistry, and geophysical datasets. For example, this is the background of this map is a geological map and overlaid with the anomaly area. And the background of this one is a digital elevation model overlaid with the resistivity map together with the contours and these structures, faults. and these points are geochemical sampling points on top of it. So this can help decision makers to make right decisions on locating geothermal resources. Interpretation of geoscientific data. Data sets can be carried out to extract lineaments such as fractures, thermal anomalies, distribution of alteration, minerals, groundwater springs, and so forth. On the images such as satellite imagery, data from Landsat, ETM Plus, and SRTM, digital elevation model, ASTA, GDM, and PARSA can be used to interpret different geological, geophysical, and geochemical samples. For example, here is satellite images which are used to interpret geological samples, and this can allow the estimation of the location of heat source. For example, you can see the identification of these faults in red lines, and this is in Ngorongoro crater, and other features associated with the geothermal activities. And this is geophysical techniques which can allow estimation of subsurface geology structures. This is the map of geophysics, the resistivity map, identified different features inside because it has been overlaid with the contours, as you can see. But these contour lines representing thickness of the low density layer, white lines representing gravimetric lineaments derived from the analysis of the horizontal gradient of the residual Boguya anomaly. But heavy black lines, this one, heavy black lines, this represents remote sensing lineaments that are likely controlled by the elevation variations of the low density layer. And the yellow cycle represents thermal manifestation, this one. And the square cycle, yellow square, this is the mountain, Wingoyongo Hill. Yes. For geochemical methods allow the estimation of the origin, temperature, and recharge within the geothermal reservoir, thereby indicating the degree of permeability within the reservoir rock structure. As you can see, this map showing the distribution of temperature of the hot springs, and this map showing the distribution of pH of the hot spring water, and this map showing the distribution of the electrical conductivity for the hot springs water. These are satellite images which can be used to interpret geological features based on rift features and experience. And possibility of extraction of new geological information is there. You can extract different geological information from these satellite images. And this is Landsat. Geothermal data management. In geothermal resources exploration and development, we normally deal with vast amounts of data from multiple sources. Vast amount of spatial data is generated and used in daily decision making. GIS is a very important aspect for geosciences data management, since most of geoscientific data is comprised of earth features and events which have certain relationships. In all phases of geothermal resources development, exploration, resource appraisal, drilling, exploitation and management of steam or hot water fields, most of the resource data is location-based, that is geographic data. Thus, GIS comes out as the best option for handling these informations. GIS also can be applicable in geothermal stall map, in creating different stall maps. I will show you a small short video showing the story map of geothermal manifestations in Tanzania. You will watch it in 10 minutes.
Africa's lack of access to energy cripples economy. Inappropriate use of resource devastates environment. Everyday blackouts, polluted environment. No, we don't need this. Africa needs solutions. Geothermal is the solution. Catalyzing investment for geothermal development is what we do. Africa needs solution. Geothermal is the solution. It's reliable, renewable, eco-friendly, and cost-effective. Geothermal energy solution for Africa energy needs. Geothermal energy solution. Geothermal energy solution for Africa energy needs. Geothermal energy solution. Catalyzing investment for geothermal development is what we do. Supporting geothermal energy is what we strive for. Region networking capacity build, this is what we strive for. No. Geothermal energy solution for Africa energy needs. Geothermal energy solution. Geothermal energy solution for Africa energy needs. Geothermal energy solution. Our objective is to encourage developers of geothermal development in East Africa. In East Africa, no. Our objective is to encourage developers of geothermal development in East Africa. In East Africa, no. Geothermal energy solution. Geothermal energy solution. Geothermal energy solution. Geothermal energy solution. Geothermal energy solution for Africa energy needs. Geothermal energy solution.
you for watching. This is how GIS can be useful on creating story maps and send the information to the people who even don't know the meaning of GIS. Also, I've just tried to show the distribution of geothermal potential energy in worldwide. The areas with the red color representing the areas where geothermal energy is available. Thank you for listening and be blessed.